SQL Server, NSK, DB2. What else? MySQL? Hadoop? Redis? Postgres? It's under there, yep. Access. Hmm?
We saw somewhere we use Access.
No, my wife's always using Access in it, asking me for help with her SQL, and it's like, I can't even read it. It makes my head hurt. Now I've had to start learning Postgres because now I'm on the Hyper project. So Hyper is basically a Postgres compatible database. But this talk's not about Hyper. I think I can a little bit. They said, don't say anything. Well, they already did. Yeah, it's a real database. It does inserts and updates and does everything like a real.
When it was pulling that data, where was it pulling it from? It still puts pressure on finding the source, right?
It's good at doing both at the same time. But it uses it would have had to have been local. It certainly wasn't.
I mean, I'm still time limited based on what my primary source is.
Right. You can only. Yeah, it's very likely that you'll become source bound. It's all in memory. I mean, it's the idea is as these machines are getting ungodly size RAMs, you can start to put what we would have considered a gigantic database in RAM, which is it's still kind of mind-boggling. Except there's always a size that doesn't fit, and then what? It's like,
I still got to get it there.
yeah.
It's still going to be like in a TDE format if I have it in that database that if you know the plan is, I can get to it from other outside of Tableau.
The original Hyper had its own data format, and so we've morphed it so they can also read TDEs just for pure convenience, because it just makes everyone's life easier. But for really doing high-speed stuff, there'll probably be some choices in the future. Probably not supposed to say all that, but
That's why I'm asking.
yeah. Well, the TDE is optimized for fast queries, fast scans. So it doesn't really make a super general purpose format, but it's really good for what Tableau normally does. So it's quite a feat to have a general purpose database, be able to read as fast as a super specialized, memory, read-only TDE. Am I supposed to wait for 10:45? Can we just start? Okay. Is this thing working? All right. Because no one else is going to fit in here anyways. All right, so this talk, what? You have to wait? Okay.
As soon as she gets back, if you're ready to go.
She ran off. Well, I'll give you a preview. So this map is kind of distorted because everything has to be 16 by 9 today. But who's been here? It's spectacular, right? I mean, whenever I have a person that has never been to any national parks, I always say, well, if you're going to go to one park, you got to go to Yellowstone. But it comes with some challenges. Yosemite is really pretty. Especially if you're in San Francisco, you can just drive there. Yellowstone is in the middle of nowhere. Unless you're going to Jackson Hole for some reason. Has she showed up yet? It is wicked fast. When I first saw the demo, being kind of a crotchety old, database person, I said, no way, that's fake. Let me look at that thing. So now I'm working on hyperperf. It's kind of fun. It's, typically when you're doing performance work, you're always working with something that's kind of broken and you would have done it better, and it's like you're just trying to make something that was put together wrong limp along. That's kind of the life of a performance person. You don't get to work on the fast stuff. You work on the slow stuff. So hyper's kind of fun because it's the guys working on it are like performance maniacs, and they just do things the way performance people think everyone should do things, but it's pretty rare.
How do they check the performance? How do they do it? I was in performance for a while.
Well, one thing we do is, because I'm doing it, is just comparing it to TDE perf for read-only stuff on a huge assortment of selects. So we started mining the workbooks in the public, the public hosts. There's like 600,000 different workbooks written by some wizards and some crackpots. I mean, it's just this range of like, what? Is that legal? But it gives us like this huge amount of things to say, well, if it worked before, it should still work. And it should give you the same answers, and it should definitely not be any slower ever.
So maybe just looking at the different things.
Yeah, right now we're focusing on the crazy select performance. It's already optimized for like TPCH and the various benchmarks. They've published papers. You actually just kind of Google it. You can find all their benchmark results. So doing standard benchmarks, it's like crazy fast. But there's benchmarks and there's life. The queries that you see in a benchmark are about 20 lines long, and some of the queries that Tableau generates are 14 megabytes of text. These aren't good queries. These are not recommended, best practices, but if you let people do stuff out in the wild, they come up with some crazy, I think.
So is the performance for like BizSQL, the visualization engines going to get much better when we put Hyper in? So like concurrency issues on server and that kind of stuff, will that get diminished because of the speed that Hyper is running at?
The fundamental law of performance is that it only matters where you're slow now.
Right.
And if you had a thing where it spent most of its time in the data engine, then Hyper could help. But if you have a viz where it spends most of its time in VizQL laying out the picture, then it can't help.
So that just depends on how you put your workbook together today?
Yeah. It just depends on, because an awful lot of the stuff isn't all that big data-wise. And so, like especially if you're looking at the public stuff, it's all kind of small.
If you're doing something with massive filter stuff, like drop-down filters and choices and that kind of stuff, What's the usual API stuff that usually goes through?
I will tell you how to fix filters. That's mostly what this talk is about. You don't need no fancy technology for filters now. You just need to have a DBA in the room. Which is against our religion, right? You're supposed to be like, oh, you can just do whatever you want. You don't need to talk to the DBA. It's like, oh, yeah, you do. You'll need to make friends with that DBA and buy him a beer or something. Is it ready? All right. All right, so back to Yellowstone. So there's a few things that Yellowstone's awesome, but you got to be careful. We'll call them challenges. So a lot of wildlife, right? A lot of interesting wildlife in Yellowstone. One of the reasons to go. But wildlife is a two-edged sword. So all of these challenges have a remediation. So what would you tell somebody, about how to avoid this problem in Yellowstone?
Don't leave food in your car.
Hmm?
Don't leave food in your car.
Okay, don't leave food in your car. This is also, I would say, drive carefully. Don't hit the animals. Because they're really big and they will break your car. You got all these cool thermal spring things, but what else do you have to tell somebody? Stay on the path. Don't go walking. Don't go swimming. And kind of a classic problem with the buffalo. Don't take selfies with the buffaloes. So it can be a dangerous place. But it's also the most popular park in the country, and it's the coolest park. So there's just some challenges, and you have to be careful. And I would say large production databases are sort of similar. There's challenges. You got to be careful. You shouldn't have a heart attack. You shouldn't run away screaming. Although I would sympathize with anyone that does run away screaming, because it's not an easy life to have the phone ring at 3 in the morning because something else happened. So what do we have for challenges in pretty much what I'm going to call a large production database? And I was saying before, large to me is just a pain in the neck. If it's small enough, you can get away with murder. If it's large, you can't. And the numerical number for what's large changes every year, but there's always something that's a pain in the neck. With Tableau this year, I would actually put the line about between 1 million and 10 million rows. That if you got 1 million rows or less, you can just let people do whatever they want. They're not going to hurt themselves very much. They're not going to hurt you. The problems with a large database all come kind of as a clump. One is if it's really super big, you can't just make a copy. Making a copy is going to be torture. Because one nice way to deal with the ad hoc viz crowd is to say, hey, here's a copy of the database. Go run along, because I don't want you screwing up my database and getting me phone calls at 4 in the morning. But if it's 20 terabytes of data, it's it takes a week to copy. So you can't. Copy is going to be a pain in the neck. The other thing that's kind of crucial to me is to me a large database is if I say select count star and then get remorse. It's and remorse for me is about 11 seconds. 11 seconds is where the perceptual research has shown that people forget the question they asked. If you look at web page abandonments, 11 seconds there's this magic cutoff of I forgot what I was doing. The other problem is they take such a lot of space that you can't easily even just maintain copies. They're just a pain. the production aspect is just as crucial. So I'm assuming that when you have a production database, you've got a lot of users, a lot of important users, and if you screw them up, you'll hear about it. And the data gets stale. I mean, one thing that's, if you have data that doesn't get stale, then Tableau can be pretty easy, because I can just give everybody the copy from Monday, even if it's big, you know. But if they want live data, and it's big, it's like the Venn diagram of things I can do starts to shrink. It's like, because Tableau, if you're not careful, will lock the database. It'll lock up tables. And this is kind of the main reason why I wouldn't let random people attack my database, because one guy can just kill you. And it's going to impact a lot of people. Like, I don't like anyone to suffer slowness, but if a guy does it to himself, it's like, well, it's you. But when he makes it slow for everyone else, then it's more of a catastrophe. The other problem from the point of view of the Tableau guy, the Tableau user, is, there's a DBA. Hopefully there's a DBA. Actually, sometimes you get these cases of these giant databases that seem to be running on their own. And then, I don't know what. We'll just not cover that. But the database has probably been in business for quite a while. And it's optimized for doing the thing that it's doing. Like a banking system, right? I'm kind of used to automatic teller banking systems. So, you're going to put your card in. The system's going to look up your account by your card number. So you're going to have an index on card number. So anything that you're doing by card number is going to be super fast. I can't think of any conceivable ad hoc viz query that would care about account number, right? So the viz people are going to be saying, well, what about the people from Austin versus Dallas? What was the largest transaction, that we did last month? Well, you probably don't have an index on transaction amount. So all kinds of problems are going to rip through, this transaction list of 1 trillion things, because questions that make sense from an analytics point of view would not have been anticipated by any normal database. And no production guy is going to put an index on every single field. It's optimized for what it's doing. So those are kind of the challenges that we kind of want to find a way to work around. And so this presentation is my journey as a person with a big database trying to use Tableau and what I ran into. So just to motivate, what order do you run into these problems? I was lucky partly because I was my own DBA. So I could go back and forth and argue with myself. So I'm kind of coming out of the old database perf world. So I'm used to knowing, just looking at a query, if it's going to be fast or slow. And put my effort into building the database that would go fast. And I figured, hooking up Tableau would be pretty much like, putting a nice coat of paint on a souped up car. And it would be no big deal at all. Of course, it wasn't quite so simple. But I did get it all to work. So it is all doable. But I'll go through my orders. So I used to be at Microsoft doing, running all the data for all the perf testing for Windows. And we had a lot of data. And my instinct was always to keep it forever, because you never knew what question you'd want to go ask about history. And so we had a nice performing database. Of course, it was SQL Server. What else were we going to put it in? And we spent man years on the code to draw the graphs from this data. I had never heard of Tableau. Then when I go to Tableau, it's like, what? this thing I spent 2 man years on, like what? Just I could do it in like half an hour. So of course I wanted the same thing, but now with vizzes. So I was pretty excited. But drama. And I'm sure you've all seen the drama. Like, you know the story. So the basic strategy, so when you have a database that's too big, the definition of too big is if you do count star, it's going to take too long. Then you kind of have to avoid anything that's going to look at all the data. Otherwise, you're not too big, and you don't need any of this worry stuff. So we have to make sure that users only ever see a subset of data at once. Because if they have to look at all the data, it will take too long. There's a hands-on training. I don't know if anyone went to the hands-on training on Monday for desktop performance. I know one person did. And I liked some of their words that they use. They're going to repeat that on Friday. So they've got the time to go into the step-by-step stuff. I'm going to be talking about the high level, because you can always Google the details. But they call it guided analytics. So the idea is I don't let everybody just do whatever they want, because it will be painful. I have workbooks that have been worked out and optimized, and I let people use those, and they pretty much would start with a summary. Like for the performance data, right? I've got different teams all writing new code, every day, and I'm checking hundreds of different tests on all the new code. But basically, each team kind of only cares about, did I screw up anything last night? If I didn't, I don't care. I'm done. So all they really want to see is a summary of, am I happy or not? No, you're not happy. All right, what did I screw up? Well, you screwed up these 3 tests. Okay, well, how often do those tests get screwed up by other people? Or how often do they just give false alarms? So this kind of an inherent drill down approach, certainly to performance data, and most data is like that. There's a lot of people that just want the summary, and then a few people want to drill in. You can just build the workbooks for this guided analytics, so that, as long as each step is efficient, you can have 1,000 users beating on it. What you can't do is have 1,000 users making up vizzes against data that if you make one wrong step, the database will be hosed for 20 minutes while it rips through every record from the last 50 years. And again, you need, depending on what the database already has, it's useful to build summary rows, summary tables. It's very likely that the summary tables you have now aren't really the ones you will wish you had. Because as people start doing analytics on data, they come up with questions that turn out to be really neat. Like, oh, we never looked at it that way. And deep down, Tableau basically is kind of this assumption that it can look at all the data all the time and then just group it. I mean, that's kind of like what it's doing all the time, just group bys. If the data is too big to do group bys, then you've got to have a little bit of an adventure. And if there's a certain set of group bys that are super popular, everybody likes them, it just makes sense to just make a table that just does that for you. I think that's a lot of that's sort of the struggly step. If you aren't friends with your database guy and you can't make tables to do these intermediate things, then life becomes, I think, harder than it needs to be. But anyways, this is the idea. And then make sure that you got the right indexes for these kinds of queries, the kind of the standard database thing. One note about extracts. Extracts are awesome. Extracts make everything easy. If you can use extracts, use extracts. But if you have data that's too big and changes a lot because it's super active, extracts become impractical at some point because it takes, well, in our case, everybody wanted up to the minute results, like, am I okay, am I okay? But it took half an hour to do an extract. So if it's, pretty soon my database was 100% busy just trying to generate extracts. And at some point, you know, at a big enough size, at a heavy enough update rate, there's a place where extracts just can't work. It's just kind of physics.
So what is the how do you know? How do I know? I mean, because I really use extract all the time, but how do I know? And then the developer who asks, Spencer, go online, do line connecting. So just so how?
Well, I think here's the trade-off. The extracts take a certain amount of time, and it's just whatever it is. During that time, it's likely to hammer the database pretty hard because it's just pulling the data as fast as the data can be served up. How much bandwidth does your database have to dish out extracts? You know, how much are you willing to give it? And there's a point where it takes like an hour to make an extract, and you want one every half hour. So it's just not going to work. In terms of speed, I will assert that everything that you can get from an extract, you can get from a good database, but it's more trouble. And so it's kind of this self-serve versus, you know, DBA wizardry trade-off. I mean, what's nice about Tableau is you can go bam, 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 try it this way, try it that way. So if someone's developing ad hoc, you know, cool dashboards, I would say it's really a good idea to give them an extract, even if it takes days to generate, because they don't need up to the minute, you know, data to develop the questions. It's when you sort of go from this ad hoc development state to like publishing a dashboard for 1,000 people that there has to be a real significant step like, okay, this is cool. Now, what do I got to do to make this fast? Because it's, you know, once you see what the queries are, and you can kind of, it's the DBA and the viz person, sorry for all the gender. The DBA and the viz person have to like work together to basically come up with a system that can be fast. And I mean, I just know databases can be fast. It's just a matter of effort. And when there's, you know, billions of rows, the effort is non-trivial. Like even adding, you know, reorganizing an index or something can just take a while. So it's a little bit, the main problem is I think sort of this impedance mismatch in development speed. Like the viz people want to go bam, 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 you know, super agile, super, here's a new way to look at it. And you know, if the database is going to support it with live queries, it's not so easy. Especially a real production database where you've got to like get people to buy in and committees and sign-offs, and it's like, no, it's like, dude. And I think that's kind of the essence of the whole problem, is just the mismatch of development speed. I think Tableau's goal is to make it easier and easier to sort of bridge that gap. But at certain sizes, there's always that gap. So I'm not trying to hide that gap. I'm trying to say, here's what you do. But I think definitely while someone's exploring stuff, they should probably work on an extract. The problem is that they're very likely to come up with some gorgeous thing that's not practical to do, because the extract can do it fast. But you should be able to just jimmy things around a bit. So, all right, here's my little journey. Step 0, create a database that's good. Sometimes we just have to remind people that Tableau just issues SQL queries. There's like nothing weird or tricky about them. And that if you're doing anything against a live database, you just have to be in the habit of looking at the queries and saying, is that smart or is that stupid? Or I'm gonna use silly and reasonable. And once you get used to looking at some of the queries, then everything starts to become more clear about how things really work. You go from like this black box, whizzy stuff to like, oh, it's just writing queries. if you can't get the queries to be fast, you're screwed. You know, it's not going to get any faster when you add color and shapes to it. It's not going to get faster when you have 1,000 people doing something slow. It's going to get unbelievably worse. And then, just because I didn't know where else to put this, you know, if you're doing something new, and is going to be a big database, but right now it's small because it's a pain in the neck to generate test data. Be afraid, because all of the great, you know, as a perf person, of course, I collect disaster stories. It's because you didn't have a perf person. And it's almost always, you didn't try this with a lot of data. Everything's fast with a little data. There's just you must know a whole bunch of stories about unhappiness like that started with, it worked so well in testing. It worked so well in the demos with, you know, 100 rows, but with, you know, 10 billion rows, suddenly it was a disaster. We all got fired. The company went out of business. You don't really have to squeeze your eyes down here. So I just had like a normal database, a normal third normal form, kind of a snowflake schema, just like a standard data warehouse kind of thing. You know, with a long skinny table and a bunch of dimension tables. And I basically, because I'm coming at it from sort of the database guy point of view, it's like, so I have my queries all, you know, optimized. So the two main queries for performance data, testing data, is kind of like, what did you screw up today? And how does this one particular test look like over time across everybody? So it's kind of like, if I can get those two things to be fast, then I'm chortling and I'm all happy. And then like a normal database person, like when you've got a warehouse with a whole bunch of, you have a fact table and all it is ID, float. So I basically make a view which joins the fact table to the dimension table, so you have a nice pretty, you know, this team on this date, running on this machine, running this test, got this result. Just like a normal database person would do. The other thing that I did, which was like the happiest thing, was create summary tables. So where it was just, wherever possible, I did not want to go to the raw data. I learned as a perf guy a while ago to never lose any data. Like save every single run. Don't average them together. Don't take the median, save every single one. But it means you have really big fat data and you don't want to look at it if you can help it. So just keep the roll-up tables. And the nice thing about the roll-up tables is you've got orders of magnitude of shrinkage, right? So I got 1 billion raw results, but like 100,000 test passes and a few hundred teams. And as these things get up, then it's like people can do random stuff on these little tables. I don't have to like be Mr. Policeman. You know, if we have 100,000 row summary, you can let people party on it, because most Tableau Viz people don't really care about the excruciating, you know, iteration 3 on Tuesday on that machine got this weird number. So they could be really creative on most of the questions. So at least you start to get, you know, you bridge that gap of I want to do everything fast and self-service versus I need to guard my database against catastrophe. The more roll-up tables you can make, the kind of the safer everything is. The big data, of course, I can't do a count star on it, so I certainly can't do a scan or anything else, a sum. So I'm going to basically attack the giant table with a where clause, right? And on Tableau, I was like, hey, we have these nice quick filters. It's perfect. It's just setting up a where clause. I need a where clause to be in business, so this should be just snap, bam, boom. I want to do a filter on which team is running the test. I want to do a filter on which test is it. I want to do a filter on which machine was it run on. And I was so happy how easy it was to create filters. So I'm charging in. So this is the kind of step one, connect to the database. And for goodness sakes, you have to make sure that you read uncommitted data. So Tableau's bias is that you should always see correct data. We shouldn't let people accidentally see wrong data, because that way leads to data unhappiness, and we're about truth and justice. But if you're going against a production database, the way it does this, right, is it's going to wait for locks, and it's going to lock stuff that it reads. So this lets one person basically just tie a production database into a knot. It's really crucial. But I'm still happy. I do that. I remember that to do that, and I can add this is my view, right? Adding my view to the whatever you call that sheet, and it throws up the data and everything's fast. This is a pretty good test, actually, because it's going to do select top 1,000. You can go look at the SQL. And if this is slow, you should just stop. You should say, wait a minute. If I can't do this, I got to go back and figure out why I can't even do this.
So, I have a SQL and I'm running stored procedures, and so I bring over the stored procedure to run here. When I run it in SQL, I know I have a performance issue there, but let's say that runs for like a minute and 30 seconds. But when I bring it over here, it then slows down to 4 minutes.
Let's see. I think all I can say is I tried using stored procedures, because I've got 50,000 lines of stored procedures to put the data in here. I could never get them to be fast. I finally just gave up. That doesn't mean they can't be done, but I don't know how to do them. You have to use them.
Yeah, the way I'm, yeah.
All right, I'll take a note. Well, it turns out views don't work anyway, so we'll get to that. So this was when I was still happy. And then I want to start putting pills on the worksheet thing, and it just starts to take forever to do anything. I mean, I'm just thinking my computer's dead, but I can no, it's working this little butt off. What's going on? So this is kind of like a nice little detour as to how do you do perf analysis with Tableau if you don't know. So the thing that Tableau does let you do is it lets you look at the queries. And especially if you have a big database, it's probably the query that's killing you. It could be something else, but it's not. It's the query. And you can, and you know the ancient war between the werewolves and the vampires? And they just for thousands of years. Well, the same thing is between performance people and the UI people. We just, I don't know who started it. It wasn't me. It predates me. So there's a nice performance recording built into Tableau, but the UI people have hidden it to the point where no one ever finds it by accident, that's for sure. And I keep forgetting where it is. It's under help, settings, something, but somewhere, and I think they move it just once too many people have found it because they don't like us. Well, because we give them a lot of trouble. Who else is going to make things slower except the UI people? It's look now, it's animated. Just find it, it's there. And it brings you up a little new picture brings you up another workbook. And the workbook basically gives you a little Gantt chart of what's taking the time. And if you have a big database, it's the queries. If you click on the queries, the text shows up down here. Is this? Oh, I can't draw on it. And the UI people, since they hate us, they show you 3 lines of query, and an awful lot of people think that that's the whole query. Of course, you know it's not the whole query. But you can copy and paste the thing out of there, and the whole thing's there. So what you want to do is basically get the query text out of this silly little box and put it into you all have a query analyzer tool, right? Depending on which database it is, it's just a different tool. Just put the query in your tool and say, database, why are you slow? And every database has a way of telling you why it's slow. And if you don't know it, someone knows it. Just make friends with a guy who's used to doing that. The person, and typically you'll just look at it and you'll know. It's like, what are you doing? What are you doing to me? In this case, so this is basically, so I got this database, I got my nice little view. Every query I type in is like fast as half second. So I'm pretty smug. But as soon as I drag on like, what was the run date time of the test onto the shelf, because I want to get a graph, it executes this query as basically, it's going to be grouping by year. In fact, it's even more painful than it looks, because it's going to go through every single row of my billions and billions of rows. It's going to parse the date to get the year, of which there's 2 years. And it's going to basically, you can look at the old school way on SQL servers. You could use the set statistics IO one, which is it's obsolete, but I'm just used to it. But there's always a nice way to figure out what's going on. And effectively, it's reading 4 billion rows to say, hey, you've been running tests for 2015 and 2016. It's like, and because my database isn't really, really big, at least it comes back the same day. But if you have a database that's really, really big, this could take a long, long time. And so, especially as I try to describe stuff to, not database people, but like our own support people about why something is slow. And so there's cheap and expensive, right? So flying to Australia is not cheap, right? It's kind of expensive, but is it silly? It's like, well, I don't know. I went to Australia a couple of years ago to see an eclipse. That's where the eclipse was. But, you could fly to Australia to borrow a cup of sugar. And you would kind of say, well, that's silly. But why is it silly? And it's silly because it's expensive compared to the alternatives. Like, I could have borrowed a cup of sugar from my neighbor. I could have just gone to the store. So most of the performance problems, it's never really black and white. There's things you do that are expensive but worth it, and there's things you do that are expensive but silly because you didn't need to. In this case, I certainly didn't need to know that I've been running this test for 2 years. So it's clearly silly. But then you get into this whole, is it worth this? There's things that just aren't worth optimizing because they're just fast enough anyways. And so this is where there's a couple of mental math things that I would like everyone to do, just from a performance point of view. If you're ever looking at a Tableau viz against a database, is how many marks am I looking at on that screen? And is that a crazy number? It's on the lower corner of the viz. I don't know if you've, the lower left has got a count of how many marks. And it's kind of obscure, but it's a magical number. Because a lot of times it's way more than you think it is. Because it doesn't necessarily look like a lot of marks. So that's how many things did Tableau compute. And if it's like a million, then, because I've had 1,000,000 marks. 1,000,000 works, 10 million starts to not work, 100 million will make your machine explode. But it's fun. You can kind of just look at that visually and say, was that silly or not, right? If the number of marks is reasonable, then you can also just go to the database and your database wizards say, how many rows of data did I look at to generate those marks? So let's say I have 1,000. Well, in this case, I got 2 marks, 2015, 2016, and I went through 4 billion rows, so 2 billion rows per mark. So that's clearly expensive, and it's pretty intuitive that it's silly. Does that all make sense? It's just kind of like, they don't let me say stupid or anything. I can only say silly. But they didn't like silly either. I could not come up with another word. Lots of things are expensive, and perf guys are always kind of knee-jerk against anything expensive, but it's like, we didn't like it when bitmap screens came along and fonts. Because you went from like 2,000 characters, could, back up a display, and now you got like megabytes of bits. It's like, it's so inefficient. But it's pretty, so maybe it's not silly. All right, so you can avoid the silly delays by some simple things. You can just say, don't automatically update the screen every time I do something. Because I'm dealing with big data, especially as I'm setting up filters and kind of get the screen that I want. Like, you don't want Tableau to keep helping you by displaying summaries of all the data until you've got enough filters in place to say, okay, now it's not a crazy amount of data. And this was really great. And then I could say, okay, let me do a filter, and oh my God, it took minutes. And this was a surprise to me. I think it's a surprise to everyone the first time they realize it. But typically, if you've got a graph based on gigabytes of data, giga rows, and you're showing thousands of dots, and you have a filter, we're working harder to just show the 5 things in the filter choice than to show the thousands and thousands of dots. Because, the only fun filter is, show me the relevant values. I don't want to, if I was going to type stuff in, I'd type stuff in, and things would be fine, but I don't like typing. I like multiple choice questions. And so once you see the query, it's kind of obvious. It's like, oh, so my tests come in groups. And for it to simply populate the members of the filter, it's going to say, well, yeah, select test group from this giant view, group by the test group, or select distinct, either way. And it's going to go rip through billions of rows to give me my 5 different test groups. And there was no way around it. That's why I was sad. It's like, I can't look at big data without a filter. I can't populate a filter without looking at billions of rows of data. Then I had to go home and drink margaritas, curse everybody. That is it's why people think filters are slow. Because it's like, well, if each one of them is ripping through all the data to come up with the distinct, members, then yeah, it's going to be more expensive than anything else we do. But if you go back to the tables, right? I had this nice data warehouse, right? The Snowflake. My list of teams, there's only 100 teams or so. Like, have a table of teams. It's that if you only use the view doesn't know that there's a little tiny table of teams. Maybe I can just build a filter off of the little table instead of the giant, ridiculous view. And there's kind of 2 ways to do it. One is you could simply throw the view away and go back to the original tables, which eventually I did. But for a quick test, it's like, I guess I could just join, in this case, all right, I'm doing test names. I'll just join this little tiny table of a couple hundred tests to this ridiculously big view, and then see if I can build the filter off of just the short table. Cross my fingers, learn about join culling and blah, blah, blah. And yeah, it works fine. So here's the main trick is you can build the filters off of your dimension tables, your small dimension tables, and everything is just a joy. And sometimes it doesn't work for fussy little reasons, but it's terribly obvious when it's not working because nothing's coming back. So one of my safety tips is if you're working with a Viz person and you're the DBA or either way, just train them. If something doesn't come back in 10 seconds, just cancel it. Everyone out there is waiting, all the users are waiting for you to stop that query. Just be quick to cancel, because if things are working, it's a second. And if it's more than a second, it might be an hour. It's kind of a U-shaped curve of performance pain. When it's not working, if you look at the query, you should usually be able to figure out why it's not working. It's like you have to make sure that the filter is just based on facts from the little table, and the query should not refer to anything in the big table. Because if it's doing a join to the big table, you'll be sad. You have a question? Or?
No, I was just going through my head.
Yeah, so that solves the filter problem. And then it's just kind of a matter of some other little gotchas. And part of the problem, I think, is if you have silos, if you have like, here's your viz people and here's your database people, and they don't work together, I don't know any way you can get this to work. Because a normal database person, which I was, I think, says, hey, I gave you this beautiful view. Every time I select anything from this view, it's as fast as heck. If the viz person now has to do a join to the little table, they're going to have to do the join for it to be fast on the ID column. But you probably, normally when you do a view like that, you don't expose all the little integer IDs because they're kind of ugly. So now you start to need a new view. Or maybe you just go to the tables. Or maybe you just like create a data source of everything joined up and say, here, just use this, viz person. And just keep checking the queries. I mean, that's the only important lesson is you can look at the query and figure out why it's slow. There is kind of an annoying product feature, which is we log the text of the query and when it finishes, and we know how long it took. So if it takes infinity time, which to me infinity is 10 seconds, anything bigger than that, you don't get the query. So anything you cancel is gone, which is another reason why the viz person has to make friends with the DBA, because the DBA can easily tell them, like, well, what was I just doing? Because it wasn't coming back. And like in SQL Server, right? You can do SB who2, there you are, what's the text of the query, here's the text of the query. And then you at least can kind of figure out what you're doing wrong. Every database has got a way to do it. So just the habit is always have the performance recording on so that you can always at least get those slow queries. It doesn't cost much. And I would just say, just abort and cancel if things take too long. If you're working off of the live database, it's kind of like on a tightrope above the electrical substation. But I'm just used to coding in production, right? Just cancel anything that takes too long because you don't know how much pain you're causing the other users. And if you have one person doing this and they're reasonably well behaved, you can get away with it. You can't really have 1,000 people doing it because they won't all. Too many people go off to get coffee because something takes too long. And if they've locked up a table, then the DBA starts to get angry. Some of the queries are going to be slow for good reasons, and some of them are going to be slow for silly reasons. One of the problems I had a lot was it's really easy to do joins on the wrong columns. In fact, Tableau is a perfect product. Never makes a mistake. But every now and then, it picks a pretty random thing to do a join on. And sometimes you just don't know. Like a lot of times you're looking at I got names, but I don't have employee IDs. So you do a join on employee name, but of course there's no index on the name, or maybe there's not. So now you've got painful joins. Because if you aren't working with a DBA, you don't know which of those columns have indexes on them. Tableau doesn't tell you. You can you're bound to make mistakes. So even though the logic is valid, it's really slow. There's this fussy thing. I guess we have some time, so I will just warn you of this fussiness when you're doing these filters on the little tables joining to the big tables. Tableau, in its zest and zeal to never show you wrong data. So if I want to say, show me all the teams that are doing performance tests. So there's a team ID in the giant table, and then I have a table of teams. Technically, it might be true that there's a team that ran a test that isn't in my team table, right? Could happen. So the only way to be sure that I'm giving you a list of all the teams that actually ran tests is to go rip through the billions of rows to say, okay, here's the unique teams. And that's the strictly correct way, but it's really slow. If you have referential integrity set on, which I do sometimes, Tableau will say, oh, you've got this foreign key relationship. So according to the foreign key, this table of teams, you can't have anybody in here that's not in the little table. So then it will do this wonderful join culling. It'll say, all right, I'll just use the little table. But if you have a really busy production database, a lot of times you start cheating on referential integrity because it's just too expensive to check on every insert. So what assumed referential integrity is it's basically saying, just pretend I have referential integrity because I would have, but I turned it off because it was too expensive. And then Tableau says, oh, okay, fine, then it's on you if I, give you a lie and forget to give you a team that really ran a test. So you'll see this referential integrity button, and you'll see people talk about it, and it's so confusing, but that's mostly what'll happen. And as long as you do my fundamental theorem of always check your queries, what you'll see is, hey, you went after the big table when I expect you to go after only the little table. Why? And it's mostly will be this thing. Another trick is when you're setting up vises and you're setting up data sources, you can have more than one data source. This was kind of new to me. And so you can have like a data source that just has kind of the smaller tables, and people can go to town on it. They can't hardly hurt you. And when you use action filters, which I'm going to talk about, you can have an action filter that says, I'm going to click on this guy here, like the team, I'm going to get to the team details. And the team details might be coming from a whole separate data source, which could even be a different database. So the action filters can jump across data sources. My instinct just is sort of, because you look at the diagram of tables, when you drag the tables out, and it kind of looks like an ER diagram, right? And you just think, oh, I should just have all my tables here. That turns out to be unhappy. It's like, it doesn't have to be complete. It's not really the same thing. It really is much more of a cube definition. Like, it kind of wants to say, everything on here I'll grab. And then you are talking it into, well, don't grab so much, please. But it's okay to have multiple ones to jump back and forth. I could not get things to work very well if I had like more than one enormous table in my data source. It just worked better with another data source with this table versus that table. It was just easier. And then there's sort of some practical things. So when you're setting up, if you're playing in production, like we all like to play in production, and you want to sort of skip a bunch of intermediate steps, one nice trick when you're doing the worksheet, because you remember how unhappy I was when I dragged that one pill on and it took minutes, and if I had a bigger database, it could have taken hours. You can set up what I would call a scaffolding filter, which is like, this is just a temporary filter until I have all the other filters in place. Then I can pull it off and hold my breath and say, it still works, okay. And the handiest filters are date ranges, because most data has dates. And you can say, let me just look at the last 3 days of data. Something that's enough to see the shape, get my colors, get all my beautiful little things. But if it does something inefficient, it's not a horror. Maybe an hour, depending on how busy your thing is. There's some set, and that's just a handy trick. The other thing is these action filters. So they were covering them in the desktop performance. Action filters, just Google how to work them. But what action filter lets you do is it lets you click on, or you can hover over something, or you can select it, which is a click, or you can actually get a menu. the hover over thing tends to be maybe not a great idea if you're dealing with really big data sets, because it just means as you roll your mouse over, it's actually executing all these different, whatever that work is. And if you got lots of dots, I always draw too many dots. Oops, I'll do that, sorry. I always draw too many dots. And it makes it expensive just to roll your mouse around. Once I fell in love with action filters, I kind of got carried away. So a lot of my vizzes now have like 10 action filters on any dot. So that's why I started just going towards menu. So for the menu, it means if you click the dot, it'll actually give you a menu of, well, do you want to see what this guy did, historically? Do you want to see what that machine did? You want to see? So they work pretty well, and you can kind of easily see what they're doing. They're picking up values from that mark, from that dot. So there has to be things that are actually unique on that mark. So that something in the detail, or something that was in the original group by, if you look at the queries. And you can use any of those values to then go to another page with these values set. And it basically just sets up the action filter. And they work great. They're just tricky to get used to. Oh, one other, this was like my last thing that like bit me in the rear end. So I had about 20 vizzes, worksheets in my workbook. And everything was fast, and I was really, really pleased as punch. And then I published it to the server to share out with everyone else, and it took overnight. And I was like, what? This is not, what the heck's going on? So when we publish a workbook to the server, what the workbook will do, what the publishing action will do, it'll actually do, like, just step through every worksheet. Like if you did the film strip view, it'll just like click on each one, left to right, just to get a thumbnail. And so if you're using these action filters to say, well, I don't want to go to the scary table without like 5 things filtered down, and he's just clicking, he's hitting a billion rows to generate a fairly useless thumbnail. So what I learned was, before you publish, step through it yourself. If anything takes more than 10 seconds, what do? Cancel and say, so when I do with the action filters, I say if I clear the filter, leave it in place. So I have to basically, if I rework the workbook, I've got to go visit everything somehow in the order that makes sense to me, so that there's some random filter on each page, so I can actually just click a page out of order. The problem with guided analytics, right, is you start at the summary and you work your way down. And when we publish, we don't respect that order. We just do left to right. So once you have the filter set up, then everything takes 1 second, because of course everything takes 1 second. And then I can publish the whole thing in 10 seconds. So everything's doable. It's just you get kind of like, it's like you got to stay on the path at Yellowstone, right? So the original talk, we were going to actually combine this talk with the SQL admin guys about like how do they defend themselves against all of the vizzes at Tableau. So of course at Tableau, you can't tell anyone no, ever. So everyone gets to cook up wacky vizzes against all the most important data. That's just the way it is. So these guys have some coping mechanisms. So that was the other talk. We were going to combine them, and then he dropped out. But I realized I actually know all the things they do. It all fits on one slide. So if you're a DBA trying to defend yourself from some creative viz people, these are the steps that we use internally. On our we call it our dog food database. We actually call it Alpo. And the first step is, I think people have also done, is you can use SQL replication to say, well, I'll have my one that I really care about. Then I'll give you a read-only copy, and I'll replicate to it. And if you kill it, well, it'll usually catch up, but it won't devastate my online stuff. And especially if you have a runaway, it's almost always just runaway queries, right? It's just almost always select count star. Or to be honest, select star. That's the other problem, is people, just get all the data. They won't survive it. Every single, so if you're building a big viz on big data, what you'll run into is we will store in memory information about every single column and every single row, right? So if I read 100 million rows and 20 columns, then I've just had to ingest 2 billion marks into my desktop memory, or if you have a server, the server memory, and it can get really big. And if you're dealing with, what we consider big, then you will explode whatever you're aiming at. So they will suffer eventually, but they probably will have gone home. You will want to have a machine that just is optimized for inefficient queries, ripping through front to back. So I'm sort of amazed at how fast a modern database can read a silly query. Even if it could be cheap, I could still consider it silly. But these guys, if you got a lot of memory, you can do a lot. You don't have to be all super careful. They have to be honest, I don't know how they do this, but they check every viz that connects to the database, and if it's not set up for read uncommitted, they simply just allow it. They just say, no, get off. We just physically force that off. Then the other thing they do is they basically have a looping thing that runs every minute to just look for long-running queries. And once they see a query more than n minutes, I think right now they have n minute set to about 5. Then they basically shoot the query and send the guy email, which is kind of nice, right? Because you know what the user, what the ID is. And they send the person email saying, you are not a good person. Oh. I'm sure the kindness police made them change that. It sends them some nice query, some nice thing about, you can do better than this. And I think what would be really nice is if it's son of the darn query, because the problem in Tableau is like if your query's shot, you don't get to see what your query was that was shot, so we can send it in the mail. It's hard. I was trying to come up with a summary that wasn't like too many things. But it's definitely possible to work with really big, giant databases if you're careful. That's all. You just have to be, you can't do it uncarefully. I think the marketing guys want it to be easier. And I think, that's where we're doing a lot of our research, is to make it easier and easier to do loosey-goosey ad hoc stuff against giant data. I think, especially with a lot of shared stuff, you have to publish curated workbooks. Like you got to make sure that, one guy can be inefficient and not really kill you, but when he shares his workbook with the entire sales force, like we have this example of, one of the sales guys came up with this viz to see if he had met his quota, and it was like horrendously inefficient. And then which was okay, but then he published it to all of his friends. So now every time we get to the end of the quarter, then all the sales guys run this unbelievably inefficient, viz to see if they've met their quota. And it's this silly, unnecessary catastrophe because it would be so easy to fix the darn workbook. So before people publish things that are going to be used by more than a handful of people, they should, the DBA, someone should just check. Is everything nice and fast and efficient? Because you get that multiplier. Once you have 10,000 people doing something bad, it's 10,000 times worse than one person. Let's see. There's a repeat right after this, right here, same place. A few other talks, databases for people that don't know databases, because they'll definitely need that. There's also the hands-on training on Friday, if they still, they might have openings. If you wanted to actually practice doing some of the things I talked about, like the action filters, where I just hand wave, that's what they'll do. I just always forget the details by the time I get home anyways, but I just try to remember that they exist and I can Google them later. You guys have questions?
You are mostly talking about Tableau on top of SQL Server. But now when we say Tableau is on top of Hadoop or Spark, where we are talking about real-time analytics, can you share some of your experience where your Tableau's clients are getting the real-time data from point-of-sale systems or from direct transaction systems? How is this performing there? Because here we are talking about getting a summary tables, rolled-up tables. So it's maybe basically T-1. We are not really talking about real-time.
Right.
So how is the performance there when you really take Tableau and put it on top of Hadoop?
Okay, so the question is, what is it like with Tableau against Hadoop and against these other things? I can't really say I know firsthand. People kept telling me to use Hadoop, and I kept saying, no, I can make this go fast. Stop making me go to Hadoop. I think in general you have the same problem of silly and reasonable. What Hadoop lets you do is quickly do unreasonable things, because I can just spend money, right? I can have, instead of spending time, I can say I can have 100 machines do this simultaneously. So now when I rip through 10 billion rows, it comes back quick. But you still burned up, you made the lights dim to answer something that was silly. So I think the cleaning up of the vises is all worth it. That's just kind of the performance person in me, just hating inefficiency. Because it's more of a agility problem, right? If you really have to be able to do stuff quick, and you got some CEO just asking random things and needs answers right away, you don't have time to do it, then I think you probably need to just have a whole bunch of hardware so I can just do things. I don't mean carelessly, but put a nicer spin on the word careless, hastily, and get quick answers. The problem is they won't scale. So if I've got a query that makes my Hadoop cluster just go for 20 seconds, I can probably stand the 20 seconds. But if I then have 100 people trying to do the same thing, well, it's only going to do 3 a minute. It's and we've seen scaling problems where people thought they had solved the problem with sheer brute force, but if the Hadoop cluster is killing itself to answer your question, so in some ways the fundamental problem goes on, and it's not that huge a thing. I think it's just if you're going to share a workbook with a lot of people, just make sure it's reasonably efficient.
So what you mentioned with the replicated copy and the read uncommitted, we went through that whole ordeal like a year ago and made it all nice. They were going to say, oh, put in a CRQ for a Tableau workbook. I was like, oh my God, no. So we fixed that. But very important question near and dear to my heart. SQL Server, custom SQL. You can do the with clause with Oracle. Will you ever be able to do the with clause in custom SQL for SQL Server?
Question is can you ever do a with clause, like a common table expression in SQL Server?
Yeah, you can do that in Oracle, have an embedded with clause in the custom SQL. SQL Server I can't, so I add, a book's worth of SQL to do something that a with clause could have.
Yeah. I have no idea. People kept asking me if I was going to do custom SQL, and it felt like defeat. It's like, I can write SQL, of course, but I think I can trick Tableau into doing this for me. I don't know you'll just have to follow up with the support guys about I don't see why it shouldn't work. I know that I've seen custom SQL, in fact, I saw it against Hyper, to be honest, using common table expression, so it didn't seem to mind. I don't know why it wouldn't work with SQL Server. That sounds like a bug or something.
Yeah, because Oracle, you can use the with clause. SQL Server doesn't like the with clause. And
Yeah.
that's implications.
All right, no, I have no idea why you hit that. Back there?
SQL Server, have you had any experience with the column store indexes?
Not yet.
I've only played around with it for 2 weeks, but I find that it has like the same performance as that extract from Tableau.
Well, it should, because it's the same technology. So the question is SQL Server with column table, the columnar database stuff, because that's the main trick that the extracts use, is it's a columnar store, nicely indexed on each column. And I don't know why it wouldn't work well with SQL Server. I just don't know how many people can do, like if you've got a production database with 1 trillion rows, doing OLTP style updates, converting that to SQL Server columns is a similar problem. It's a very promising avenue. It's kind of like, it's Hyper's trick as well. It's column store optimized. I think it's the future problem, maybe next year's topic, will be how to deal with column databases and not like lose your mind.
That seems to be like the right solution for Tableau. Like you said earlier, all Tableau is really doing is scanning and grouping by.
Yep.
And that's that core. So
Yeah.
I haven't heard anyone mention that.
Are we done? All right.
Hybrid is based on columnar storage.
Yeah, it's actually an option. You can, for each table, you can set it up column or row.
That was an excellent presentation.
Oh, thanks.
Yeah, it's near and dear to my heart because we're doing like